So in this question, we have a tennis ball that is bouncing its wall at 45 degrees and it bounces off at 45 degrees. And we are given the mass and velocity of the tennis ball, and we are asked to find the impulse exerted in this collision. So how do we find that? I think firstly, let's try to decompose the velocity. Before the collision, we have 45 degrees. So that means we have two components. The component that is perpendicular to the wall is square root of 2 over 2v, and the one that's tangential to the wall is also square root of 2 over 2v. After, let's call its velocity v prime, and we have the same thing. We have square root of 2 over 2v prime and square root of 2 over 2v prime. So now there is this really tricky point, is that when you look at this picture, you'll find it to be vertically symmetric, meaning vertically it's the same angle, it's both 45 degrees here. So in some ways this motion is almost, you can think of it as being reversible in the vertical direction. So that could only be possible if there is no vertical impulse, if the vertical momentum of the ball does not change. That's the only way it can be symmetric in the vertical direction. So because of that, we actually have square root 2 over 2v prime equals to square root 2 over 2v, or it also tells us v prime equals v. This is a really tricky point, but so you might want to take some time to digest. So what it's saying is that the wall does not really exert any force in the direction that's parallel to the wall, which I think it would be easy to also just imagine, because really the only way a wall can exert parallel force is by friction force, but there's no friction force in this problem. So the wall does not exert any force that's parallel to it. It only exerts force in this direction. So from that, we know that the change of velocity initially in the perpendicular direction is square root 2 over 2v. And afterwards, it's negative square root 2 over 2v because it's in the opposite direction. These two are in the opposite direction. But the magnitude does not change. And also, this component is the only change of velocity. So that gives us delta p equals mv initial, or final, minus mv initial. Or in other words, it's if we just plug this in, actually we'll find that this is equal to 2m times square root 2 over 2v, or square root 2 times m times v. 41 times m, 0.06 kilogram times 28 meter per second, and that is 2.4 kilogram meter per second. And the direction is to the left because it was originally in this direction, now it's in this direction. So the impulse, the change of momentum, is in this direction. And again, no vertical component because it's a symmetric configuration. So that is a very important point, and you should remember that every time you see similar configurations.